where they had the shut off to the water. It was that one patch that wasn't the new piping. I'm sure it was that doesn't help too.
So how much? I see the water line like 7 inches or so.
I'd say about a foot for sure.
Just hit my head, but there's water here still.
So that's where the sump pump isn't. That's gonna have to dry up. And that is clear, so that's a good thing too. So there's water in there. I mean, like it was high, like wherever that line is.
I see the water line here.
Yeah.
I'm hoping the motor is still okay. How about the hot water? Are you getting hot water right now?
I don't even know. I didn't even check that.
So here the plumber turned off the unit. I was hoping the motor would still be good, guys. That motor seems like it was in water. No, I'm good.
Does it look like the board is fried? I wonder.
The board's done.
Like, I was
Look at this pole.
was...
You know, like everything just chills.
I can move this too.
Oh, they pumped it out for you?
Yeah, they pumped it out, which probably saved me a bunch.
Well, it saves you time. It's their screw up. Yeah. Anybody else get flooded here?
Just me.
Just you? Because it happened in that corner. In the driveway, in the parking lot?
Yeah, you'll see it when you go to your truck. You'll see the cones there.
And it's like the water feed?
Yeah, the main water line. At first we were like, oh, is it sewage? But
so,
it's not.
Here it's wet, so that is a foot. Wetness, see? Right here, that's a foot. Yeah, take a picture of all that. So I guess this is where it broke. So apparently this piece over here, guys, was still an old piece of pipe. And of course, a small piece of pipe that wasn't changed breaks. And it happens, right? That's gonna be the weak point. I doubt this is working. Absolutely saturated. Still water in there? Wouldn't be surprised if there's still water in there. Well, I guess we'll check that later. This ICP brand. I don't know if that's a good thing or bad thing. Looks like the fuse is still good. Water up there too, guys. I don't know if that's because of humidity or what, but I felt water drips. Did it go to this level? Alright guys, last call of the day. Let's check this unit out. Blower goes on, compressor comes on, it trips the breaker. So it's still powered. Ew. Heating the cabinet. Oh, it's getting dark out here, boy. Check ohms in this thing. Maybe I can hold it with one hand. Yeah, she's pooched. Pooched like dinner. I'm gonna scan that with the Copeland app, see if we can read it. Alright, let's enter. CRP5. -0450. Looks like that's the one. Yep. Hermetic. How come they're all showing R22? Let me just double check the nameplate here. Yep, it's R22. Winding resistance. So when you start, it's 1.3 and run is 0.4. I'm way off those numbers.
24 hours later.
Basically, you got your powers, your neutral line side. You got your 24 side coming in from the transformer, 120 coming from the transformer again, neutral on one side, power on the other side. You got the clip for the power of the blower, ECM, and then you got your thermostat. Pretty straightforward. Green, blower, common, white from the thermostat, heat, AC, my one and white, red. And then you got the main harness with all the safeties. What's this from? They were in this clip and they came out. You know, see? They got wires here and they got wires here. These are the situations you got to deal with, right? Looks like it's going to the blower. The orange is probably not used. There's nothing on the orange. Oh, look, you see on this side? It's all clean. Nothing there, no metal in the harness. I'm going to check the schematic online. These will probably have to be connected. When up Luon app, search model in here, F96VTN0801716A. Yeah, that sounds about right. 95% efficiency, 80,000 BTU. Okay, let's find manual. Expand wiring diagram. The big terminal there, you can't see it, screen sharing. The yellow and brown are connected and it goes to the harness. Yellow is connected, goes to the harness, and it goes to my blower motor. So definitely the yellow and brown have to be connected. The brown is some common and yellow is signal. This app is pretty cool. Unfortunately, now that you have to pay a little bit, but hey, it's convenient and it helps, right? So we definitely have to connect these. They're used, so we'll just merge them together. Pull this out. Want to look in all these clips to make sure there's no decoloration from the water, like this one. We're gonna change this clip. You don't want that green stuff. So after you take those screws out, it should just slide to the right, which it does. Something just broke in my hands. I don't know what. Oh, a piece of resistor or something. You see it. Pretty bad, eh? Water and electricity. Oh, look at the water in there. You see that? See this wood? Because there's a pit here. Okay. See the water in there still? Check that out. The wires going to the motor are totally out. That's the low voltage side. The same 2 wires are not even in the clip. Maybe see if I can find a dry spot here. So basically loosen this over here so the motor shaft can slide out. This doesn't seem too bad, so I'm not gonna bother sanding it. Then there's 4 bolts on the other side. I believe they're 3/8. I think it already fell down. This is probably okay. They'll come out. 3/8 bolts. That's 4. This should be warranty. Make sure the orientation is somewhat the same as a wire harness. There you go. All the way out, it rubs, right? So you gotta push it in, like line it up. It's even on both sides. See this flat spot here? Line it up with the set screw right there. So make sure it's all even. And tighten this up. What I like to do is tighten it all the way, score it, release it, and then tighten again. Tighten, nice and tight. Loosen it again, tighten it again. Get it down so you get nice leverage. Good. Let's put some connectors on. We're gonna chop these right off and we're gonna use spade connectors. If you're not sure, you look at the wiring diagram. Take some of these. Got hard. More. For the low voltage side, I'm gonna use these red insulator ones. Crimper. So I like how these fit in, but the high voltage side on the motor, the clips are not usually that good. So I'm gonna squeeze them a little bit. Don't do it too much, so you won't be able to get them in. And squeeze. I'm gonna use this, I'm just gonna squeeze down just to make them more snug. Then bring the motor here. These conditions are nasty, man. So let's put these on. You got your line voltage, common. For the low voltage is on the same side as the line voltage. Don't get that confused. Your speed tap is yellow. This was on number 1 and then we could check it. Common, low voltage side, line, high voltage side, ground, neutral. And your speed tap was on number 1. We're gonna keep it there for now. Ground is right here. Should be able to slide this back in. So as you see the tracks I'm lining up with? You have to start it there and both on the same side and then drag it right in. There we go. That should be good. So we'll put these screws back, lock it in place. Put the board back. Line side transformer, neutral transformer, power wire, motor, neutral wire. Here, transformer, low voltage, fan, common on the condenser, cooling coil, thermostat, and power. Let's turn on the power and see what happens. Moment of truth. Pulse. Let me jump it out. And we got takeoff. Wait, let's do heating. Remember the inducer was full of water? Fans on. It's not lighting. I don't have my door switches in my bag. Spark. Let's do cooling. So as soon as I hit the door switch, the condenser should turn on. We should hear it outside. The fan should start. Yeah, I heard the condenser outside. Fan should be starting. I'm gonna put this door on just for now so I get this nest. I'm gonna check the thermostat, see if it's charged. Doesn't look like there's a common. Back for the nest. Does he have an extra wire here? I see a wire here. And the nest doesn't have a common. So why not just use this black for the common? Yeah, look. If it's the same wire, why not use the common? So we don't have to worry about this. Yeah, there's a black there. I'm gonna add this black to the common because I bet you this might be dead. Can be dead? Actually not dead. Surprised. Oh, AC came on. That means we're gonna close the windows.
right guys, back at this unit. Compressor time. First thing at this unit, we're going to recover the refrigerant inside. We're going to be using this Y, better flow, less turbulence, 1/4 by 3/8. We're gonna put it right on the filter. First starting a recovery, evacuation, I like to put these Appion valves on. Strainer cores are inside, restrict the flow over probably 80%. Why keep them in? Like to throw these on, they make the job go smoother, easier, and they help you out, so why not use them? So you're gonna push in, push hard, twist. That should be removed. Push in hard. You can feel you grab it and you can see the stem is moving out. So you know you have it. And you go there, close, and you can close, take the shredders out. As you see, the shredder is out. That's 2. So what I have here, guys, is a 1/4, 3/8. This is a 1/4. This is 3/8. 3/8, 1/4. So now our quarters hook up to here. So now we're connected from the recovery machine to our system. Now let's hook up the out from the recovery to the recovery tank. Put a valve, just so I could valve off the recovery line. And for the recovery line, because this is a 3/8 hose, I use adapters, 3/8 by 1/4 inch SA fittings. And this is 3/8, so I'll put another one of these in here. So now you can put one end here on a 1/4 inch side, put this side. We'll keep this loose. This is closed. This is gonna be loose. We're gonna let it come through the system. We're gonna open these up and we're gonna stop it right here. Then from here, we're gonna throttle this valve until we get refrigerant out of here. Then we'll close it and open the tank. Zero out the scale and see where pressure is reading. The tare weight of the tank, the hoses on it's about 30 pounds, which is fair. We're gonna zero this out, zero scale. We got our pressure probe on there as well. We're gonna open up these valves. We got pressure coming in all the way here, stop there. So we're gonna open this in the machine and we could bleed it out here. So let's do that. We have refrigerant. Then what we'll do is throttle this with that open over there. This is closed. Tighten this up right until we get refrigerant. Slowly open it. Close it. This is still closed. Now we can open it. We're gonna open this and then flip the tank upside down so we get the liquid in the tank and it will help with heat. You don't wanna go through here because there's a drip tube. Sometimes they could be 1/8 of an inch or 1/4 inch and it restricts, causes heat. So the best thing to do is use the vapor side, flip the tank, and it'll be best for heat. So we got the machine on here. It's going automatically inside because of differential pressure. Sometimes I like to use the fan from the machine. You can put it right next to it. It's like the evaporator effect. Cool air going over the tanks. A lot of guys don't clean oil in this machine. Make it run a lot hotter than it should. Sometimes what I like to do is turn the machine off, see how much it raises, if there's any blowing of refrigerant, and then turn it back on. Valves off. So I got the regulator, nitrogen set up. I'm gonna trickle in a little bit of nitrogen on one side when I'm unsweating the compressor out. Limit the oxidation. We'll try to keep it as clean as possible. This wrench, guys, I don't know if I told you, really good. Little play, opens up big, called backhoe. I'm leaking nitrogen right through here. Crazy, eh? I'm gonna trickle in, something like that. Once I put it in here, I should feel it. There you go. What I'm gonna do is an acid test. I wanna see how bad their burnout was. Was it just a short of the windings or was it a total catastrophe? Black oil, totally acid in there. What we'll do is we'll flush it out. If the oil's okay, there's no acid, I'll add a neutralizer and I won't bother flushing the system out. So acid test on this compressor, Sporlan Testol. One comes for the mineral oil and one is for POE oil. It's in here. This was R22. So we're gonna open this. Put this inside, put this in, turns pink, shake it up. Then put oil you took out, you put it back in here. Put the solution in here. And you're gonna shake it for a good 10 minutes. This is a pass for a mineral oil. Saying a pass, what I'll do is I'll just put a bigger filter dryer, an acid neutralizer, which I'll show you what that is. Any residual acidicness will be neutralized with this. Now, if this turned totally black, it will be a fail. I would want to flush the lines out, add maybe a suction line dryer, as well as a liquid line dryer, and possibly even come back and remove the suction line dryer or liquid line dryer. Because we passed, we should be good to go. Always got a cheapie somewhere handy. There she is. Bushings. It's different, which is fine. We're gonna try roping this up. Copeland gives you new mounting hardware, vibration, rubber. The reed should be good for this time. See how it's going down? I got pressure on it. All right, got that sweated in, tops all sweated in. I got an oversized filter dryer. I went a little bit bigger. You open up the system, it's good to put a nice fresh filter inside. These are awesome. So I can isolate these nicely. I have a valve here too for my nitrogen. A high side pressure port and temperature. We're gonna use Measure Quick for a temperature compensation test. So while that's going in, we'll test the liquid dryer already. So we're doing the compensation test at the same time. All right, we passed. Woo. And pressure, start pressure. So I like this. And what you could do too is you could save this, and if you're doing reports, you could put this in reports. It's pretty cool because you and I know what temperature you can have fluctuations with different material and everything like that. Awesome. All right guys, for the vacuum pump setup, what I've got here is another Y, half in, 3/8, 3/8 hose, quarter, 3/8. I'll put my micron gauge on this port and I'll put it with a valve, like isolated after. You know, I just realized, guys, maybe I didn't know, or maybe I did know, but these are great magnets right here. Put it anywhere and it'll stay. Awesome idea. I knew I forgot something, my Nylog. Navac battery. They don't seem the greatest to hold charge, to be honest with you. So what I have here is Kita to whatever this was. I can't even remember. I shaved the sides a bit and I use Milwaukee batteries. While that's going, after it's done, what we could do is we could close off these valves, put our pressure probes on. On this side, I'll put the charge port and we'll charge it up. So whatever you see on the app, you'll see on your phone. It's going pretty quick. As you see. There you go. It didn't even lag. We're gonna change the batteries and put a Milwaukee in. And if you know, you know. Okay, so we passed our DK test. Everything is isolated. Okay, I got one on my supply. Double filter. Clean at least. Let's see if we can get that in there. Should have it in there. That's fine. What? Maybe we'll come back and do all of the duct work. It's been a long day, guys. We had that call for the board and the motor first thing early morning, then this. By yourself, it's taking a toll, bud. No sweat. We come back tomorrow. We can put the mastic on and see how it's running. Charge it today. That's the goal. I come across units that the start relay sometimes will disengage or engage at the proper time, cause failure, right? This time we'll leave it, but we're gonna change the start capacitor as well. The contactor, fix those terminals there. As you see, they're a little burnt. If you look on the compressor, it's CRPQ. So if you look here, it came with this CRPQ 450, tells you your 45, which we changed, the 45 run capacitor, and the microfarads for the start capacitor. The old one, it was different. It's good to change it on anyway, so at least you know which one to put. We could also do it this way. We could scan the compressor with the Copeland app.
Picture, scan barcode. There you go. 208 electrical capacitor, and it says the same thing, 189 227 microfarads, and the run is 45. And what you can also see is what potential relay you need, your winding resistance. Those are our resistance readings, and there you go. It tells you everything in this app. Let's go back. We go to mechanical, tells you the charge, tells you your 70 oil, your performance, condenser temp 130, 45 evap temp, tells you your superheat and your subcooling. Typically you could also change these values, and you could also calculate in here your performance. So it's a pretty cool app.
Let's see if we can measure this with one hand. This is the start capacitor. We got nothing there anyways. Better. See, it almost rubbed off. Guarantee. I'm surprised it didn't rub off. But see this? For the old compressor, it's different. This wouldn't have been good enough. It's always good to check, look up everything, and change them if you need them. So I'll let you know if you start feeling cooling, you know it's on, working. I know, right? That's better. All right, guys. So you see the new capacitor, 234, 233. The old ones always come with a bleed resistor for discharging when it's not on. The new ones, I don't know, unless they have it internally, they never come with it. Let's put this here for now. A lot of times they have a liquid and vapor port. This one just has one port. So this one here, we're gonna have to flip around for the liquid. We're gonna do a static charge, high side first, see how much we could put in till we equalize. Then we'll move it over from the high side to the low side and start the unit. 0 to scale. Static charge in the system, it gives it a chance to equalize. It goes through the condenser, just like a refrigeration cycle, goes through the condenser, through the metering device, boils off, equalizes. Then once we get a few pounds in there, so the compressor doesn't start underneath vacuum, we can start the unit. I think I know why it's not starting, guys. I didn't put the plug in. I gotta put the plug in. Oh, it's a different plug. Oh my gosh. I even told the guy at Lennox, I go, numbers are 100%. It's hard to match up. Are you sure this is the one? Yeah, it's the one. Well, okay, if it's the same one with the same BTUs, but the harness is different, so why not give me the harness? I'll document what I have inside the system already. We were almost there. You know, I was gonna come back anyways to do the mastic on the ductwork for her and to check the system, but now I gotta come back regardless. But tomorrow is Saturday, so we almost did it. Started off with the board, blower. Thank God another supplier had one in stock. I had to pay $100 fee because I didn't get the furnace through them. It's awesome I was able to get that blower that same day. He had one in stock. So we did the blower, fixed some wiring, the board, that unit's running. Then we went around the corner. This unit brought a compressor with us. Everything was going pretty smooth till we find out at the end the terminals are different. Lennox told me, yeah, exact same. Take their word for it. I should have checked anyways before the end of the day, so at least I was prepared. But it is what it is. I was gonna come back tomorrow anyways, watch her run. Hopefully I could find some of those screws. I used to carry some, keep some laying around, right? Just like anything else, you keep shit around, and then when you need it, you can't find it. I will bring you along with me tomorrow. Hopefully I find something. I'm gonna make some connectors, watch her run, can't complain. I don't mind coming tomorrow. It's getting tiring. One guy roping, carrying, and bringing all that stuff on a compressor change. You know how it is. It gets exhausting for sure. All right, before the sun comes back in my face, I hope you had fun. I know I did, and we'll see you on the next one. Peace. As you see, there's different thread. Imperial, coarse, metric, and you got machine. The usual terminals are the machine thread. They're finer thread. I'm gonna grab both, 1024, 1032. 24 to 32 is the number of threads per inch. Because I'm not sure, we're gonna grab 3 of these and 3 of these. The cost is minimal. What's good about these are they're stainless. So as you see, you get the pan heads, 1032 by 1, that's a little big. They have half inch. Quarter, that's too big. So they don't have half inch of 1032. But if you go here, 1032, get half inch. The only thing is, with these ones here, half inch, These are zinc coated and these are stainless. It'll be nice to get hex head, but I will probably stop at fastener supplier and get hex head, the 1032, 1024 Phillips pan head. Hex, hopefully they have them of the 1032. I like to put my bills right away into QuickBooks, get a picture of it, right on my leg, picture, put the amount in, a whopping 1007, business card, who I paid, tax, and I'll put some other information after. Reference number, I'll put the HSD number. Save. At least now I won't forget. With this new heater, or any heater, you don't want to be more than about 2 inches from the bottom. It should be on the crankcase, right? Hook it on there, that's it. You want it on the crankcase, there's about right. Now we could run new wires for this, but why? Because it's going to be screw-on connectors anyways. Make sure you know which one's which, common, start, run, because on this, it could be totally different. So best thing to do is, if they're not marked, and even if they are marked, you should ohm it out and double check. Run and start are going to be the most, and then isolate the run and start winding to the common to see which one's greater, which one's less. Here we're labeled, so you got your run L3, common L1, start L2. Typically your blue here is going one side of the contactor. Yellow is your start, starts coming down, goes to the starting relay, which gets power from one of the load sides, and your common goes to the red, goes to the other side of the contactor. So you got 2 legs on the contactor, and the starting wire goes to your starting side, which goes to the potential relay, grabs power, load sides. So this start winding will kick out after the compressor is running. So we confirm which wire is doing which. See, as you see here, look, the red wire turns into gray. So you always got to confirm just to make sure. We will change that contactor, redo those connections. All right, guys, I was able to find hex head at the nuts and bolts supplier, and it fits. Good thing for memory, or else we would have been here for a bit. So 1032 fits right in. 3 of these. So basically the ones I should have provided. We're gonna use eye connectors, and for the heater, these might be too big, but we could just use standard Moretz. So just in case you gotta change the heater again, we're gonna use these butt connectors, crimp them, and insulation around it. This is the only size I had. Before all that, we have to determine where the start winding is, common, run winding. So 1.8, 1.9, 0.6, 1.6. So we know this terminal and this terminal, or either or, is the start winding and the run winding because it's the most resistance. We're gonna go from run to common. So the greater one should be the start winding. 0.6, so 1.4-ish. So we know start, run, common, and the 2 windings individually should add up to the start and run together. The start and run together. Start terminal, run terminal, common. A lot of people would have just assumed the middle is the common. Well, in this case, it's wrong. These have a certain torque spec. We're gonna just give them a snug and then we're gonna torque them later. Properly torque. So since I'm underneath positive pressure, I'm just gonna put this T on this Schrader depressor. So it'll be pressure probe here, and I could put the fill there. So right now, this is open. So now we got refrigerant all the way here. Oh, I gotta see what's leaking here now. Looks like the screw. Okay, so let's try that again. We got refrigerant all the way in our holes here. We're gonna open this, take all the air that's trapped out of here out. We're gonna open it, throttle it. Close. So we know we got refrigerant all the way in here. So remember, we got pressure in there from last time, guys. There you go. So we're gonna open this up, putting it into the liquid side, high side, units off, going through the condenser, going to the expansion valve, boiling off, and then the system will equalize. Then we'll turn the system on. We'll go to about 150 and stop it. As you see, guys, look at that. We have a good almost 150 psi. So we're giving the refrigerant a chance to boil off. This is much safer since it was emptied under vacuum to put refrigerant inside the high side, to the condenser, to the evaporator, to the metering device, boiling off, just like the system is on, just so it saves the compressor. You're not slugging, you're not hydrolocking the compressor. Look at that. We're ready at 4 pounds. It's gonna equalize. So we're static charging the unit. See how they're equalizing? We're at 128. We should stop soon. Equalize. There you go. So we're gonna stop about there. Pretty much equalize. 128. We're gonna close it. So we're closed. So move this to the suction side. Start the unit. Trickle it in until we're good with our numbers. Very slowly meter the refrigerant in. Before we start the unit, let me just shrink these. Double check all of your wiring. Those are in place. Start capacitors in. Run capacitor, contactor, liquid dryer, compressor. Brought a filter with me. Take this double out. Chronometer inside. Let's do it. monitor this system. What I just realized, guys. Look crap. He's alive. So while the unit is running, let's duct seal a little bit. All right, a little better. It's a mess, so I'd rather have the little holes covered than it being so neat. We'll watch the unit run a little bit, take off the state, and let's get out of here. See you in the next one, guys. Peace. Just waiting for the unit to come back on. You see the back side of this, it's still there kind of from where I put it last time. Top where the sun and element hits it came off. Little homemade bruschetta, little snack while we wait. Looking at my phone, it looks like the system turned off. Inside is satisfied.